larger piston divided by force on smaller piston will be equal to area of larger piston divided by area of smaller piston. Okay, let's do a simple substitution. Simple substitution. For larger piston, that's what we are looking for. For smaller pistons, a small f, which is 120. The area on larger piston is 8.0 times 10 raised to the power minus 4. For smaller piston, is 4.0 times 10 raised to the power minus 2. Let's make our health the source of the formula. We are going to have, that's capital health. We are going to have this times this, 120 times 8.0 times 10 to the power minus 4, all divided by 4.0 times 10 raised to the power minus 2. And that's what we are having. So from there, 4.0, let's have this. 4 here, 1. 4 here, 2. So what we are having left now is going to be 120 times 2 times 10 raised to the power minus 4. 10 raised to the power minus 2, by the time it moves up, it will become plus 2. That's indices. 120 times 2 times 10 raised to the power minus 2. Okay? And what you are having there, 120 times 2 must give us a value. 120 times 2 must give us a value. And we are having 240 times 10 raised to the power minus 2. If we try to shift it, let's shift 1, 2. 2.4. By the time we shift it, this one will become plus 2. Minus 2 plus 2, 0. Everything is 1 now. And we are looking at is 2.4 Newton. 2.4 Newton. And that will be the force that we pushed up the load. Let's consider another new topic, liquid at rest. Under this topic, the candidate should be able to distinguish between density and relative density of substance. They should be able to determine the upthrust on a body immersed in a liquid. They should be able to apply Archimedes' principle and law of flotation to solve problem. Let's quickly consider the following. How do we define the density? Density is defined as the mass per unit volume and is usually symbolized, we call it rho. It's defined as mass per unit volume. That is, density is mass over volume, which is M over V. The unit of density for mass is kilogram, for volume is meter cube. When you take it together, we have kilogram per meter cube, and that is the unit of density. Another thing we need to consider is relative density. How do we define a relative density? The relative density of a substance, in this case, the substance can be a liquid, can be water, can be oil, can be a petrol. So, relative density of a substance is defined as, you can have density of substance divided by density of water. It can also be defined as mass of substance divided by mass of equal volume of water. This same relative density can be weight of substance divided by weight of equal volume of water. Let's quickly say something about Archimedes' principle. Archimedes' principle states that when a body is totally or partially immersed in a fluid, the fluid in this case it can be a liquid or a gas fluid. So the Archimedes principle states that when a body is totally or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of fluid displaced. The formula for upthrust, let me tell you, upthrust is a force in this case, which is equal to, we have what we call rho Vg. The rho, which is our density, density. Okay, this is density of the liquid. This is the volume of the liquid, and our G is the acceleration due to gravity. Density of the liquid, this is the volume of objects, not of the liquid. Density of the liquid, volume of the objects, and this is our acceleration due to gravity. So this is now the formula you can use to calculate the upthrust. From here, we will quickly go and solve the following question. So let's see how the following question can be solved. Question number 1. The question says, what volume of alcohol with a density of 8.4 times 10 to the power 2 kg per meter cube will have the same mass as 4.2 meter cube of petrol, whose density is 7.2 times 10 to the power 2 kg per meter cube. We define density as mass over volume, which means mass can be equal to density volume. We are told that we have two substances, they have the same mass with different densities and different volume. Once we have the substances that have that condition, we can now say, since the mass of the first substance is equal to the mass of the second substance, automatically we can have density and volume of the first substance to be equal to density and volume of the second substance. You can call for the first substance, let's call it density 1, volume 1, density 2, volume 2. Let's now take it one by one. What volume of alcohol we get? Let's take our O1 or E1 to be density of alcohol, which is 8.4 times 10 raised to power 2. We are told what will be the volume of alcohol. That is what we are looking for. Okay, let's take our E2 to be equal to the density of petrol, which is 7.2 times 10 raised to power 2. Then let's take V2 to be volume of petrol, which we have been given. We are told that petrol, whose density is 7.2, we have a volume of 4.2. 4.2. So let's try and substitute this into this. What we are going to have for our E1, which is 8.4 times 10 raised to power 2 times V1, and that's what we are looking for. Then E2, 7.2 times 10 raised to power 2 times 4.2. Then let's make V1 7.2 times 10 raised to power 2 times 4.2, all divided by 8.4 times 10 raised to power 2. This cancel this straight away. What we are having next is 7.2 times 4.2, 8.4. Let's take it one by one. Let's multiply 7.2 by 4.2. We have 30.24 divided by 8.4. That is 3.6 meter cube. And that will be the volume of the alcohol. Question number 2. The question says an empty 60-liter petrol tank has a mass of 10 kilograms. Its mass, when full of fuel of relative density 0.72 is, we are going to have the relative density to be equal to mass of, they're going to be mass of liquid, and the liquid is petrol. In bracket, let's have petrol divided by mass of equal volume of water. If you look at that question, we have been given a value for relative density, which is 0.72. Let's put it there. So we are looking mass of liquid, which is still our petrol. Mass of equal volume of water is going to be 60, because we are told that an empty 60 liter of petrol. Okay, so let's look at what will be the mass of liquid. It will be equal to 0.72 times 60. 43